We have all heard about evaporation at some point. What exactly is it? Evaporation is the process of a liquid substance transforming to its gaseous state when it receives external stimulation, generally in the form of heat. Heat energy is absorbed by liquid molecules, some of which break away from the linkages binding them to one another and are released in the form of vapor, or in other words, the liquid evaporates. A common example is the drying of damp clothes hung out in the sun. Damp clothes consist of water molecules bonded loosely with the cloth fibers. Energy from the sun and the wind flow through these clothes, carrying with them some of the water molecules, eventually drying the clothes. Simply put, clothes in the open dry due to evaporation. That was evaporation. What about evaporative cooling? When air passes over a stream of water, water vapor is added into air, lowering the air temperature. The energy needed for evaporation is taken from air, and the loss of energy is reflected as a reduction in the air temperature. This phenomenon is called evaporative cooling. A very common example is one we all experience on a daily basis: perspiration. As air passes over the skin, evaporation takes place and a cooling effect is felt. This is because the sweat takes away some of the body heat during evaporation. Now that we know what evaporative cooling is, let's look at the two types: direct evaporative cooling and indirect evaporative cooling. In direct evaporative cooling, warm air from outside is pulled through moist pads where it is cooled due to evaporation. The cool air with added moisture is then drawn to the space requiring cooling using a blower. The second type is indirect evaporative cooling. Here, we use a sensible heat exchanger as the medium. It consists of alternate panels allowing wet air streams and dry air streams. Water is allowed to drip on the heat exchanger into the panels allocated for wet air streams. The fans are switched on, and as warm air passes over the wet surface of the heat exchanger, water on it evaporates and the material of the heat exchanger is cooled. Air is then passed through the dry panels of the heat exchanger, where it is cooled by virtue of its interaction with the cool surface. This cooled air, without any added moisture, is let out at the other end. In indirect direct evaporative cooling, air is cooled first with indirect evaporative cooling and then cooled further with direct evaporative cooling.
How does the Colorado system do it? Check it out. The heart of the system is the heat mass exchanger, or HMX, made up of thin plastic sheets they call plates. The specially made plates contain channels that draw the moisture. At the Colorado factory, the sheets of polypropylene are cut, stacked, and pressed. Next, they frame them up. With an inlet for water added, it's ready to go.
Typical solar hot water system. Water is heated by solar panels and stored in the hot water tank. This solar hot water can then be used throughout the home, reducing the need for gas or electricity. A portion of the hot water is diverted into CSIRO's new solar air conditioning unit, which is divided into two compartments. The hot water enters a heat exchanger in the first compartment of the unit. Similar to a car radiator, the heat exchanger uses the hot water to heat outside air that has been drawn into the first compartment through the vent. At the same time, outside air is also being drawn into the second compartment into a desiccant wheel. The desiccant wheel is the most critical part of the system. It is used to dry out the air before it goes into the house. Slowly turning, the desiccant material in the wheel continuously absorbs moisture in the second compartment. And then the absorbent material dries out in the first compartment. The desiccant material is dried out using the hot dry air generated by the heat exchanger. This air is then exhausted outside the home. The dry air from the desiccant wheel flows through an indirect evaporative cooler, which creates a stream of cool, dry air. This cool, dry air is then fed into the home in order to cool down the rooms.